I found out after they made Interstellar, some of the folks told me that when I was on the International Space Station and I did a cover of a David Bowie tune, and they were trying to decide how to light Matt McConaughey's face when he was looking through the windows of his spaceship, they actually looked at that clip of me to see how the actual light on a spaceship looked, and then they sort of mirrored that when they were lighting Matt's face. It made me laugh that art imitating life, imitating art. My name's Chris Hadfield, colonel in the Air Force, astronaut, flew in space 3 times, commanded the International Space Station, did 2 different spacewalks, used to be a test pilot, engineer, downhill ski racer, occasional guitar player, and we're here today to look at some scenes from different space movies.
You need to detach. I can't see you anymore. Do it now.
This is Gravity, and this is the scene where the Space Shuttle Explorer is orbiting the Earth and they're doing repairs on the Hubble telescope and they go through some sort of asteroid debris field. Okay, well that's a nice concept, and the visuals are great, but what happens is so far from reality that I want to turn my head. First off, this satellite goes whizzing by at about, I don't know, maybe 120 miles an hour. Satellites are going 5 miles a second, 17,500 miles an hour. How that thing where you could identify the satellite going by. And then it's like some big dump truck just suddenly put this big pile of rubble just upwind of the space shuttle. And suddenly it looks like an avalanche in space has poured in front of this shuttle. And they violate the laws of physics when Sandra Bullock, she's on the end of the big Canadarm, the big robot arm, and it's tumbling, and she releases her little straps, and suddenly, whoo, she flies away in a whole new direction, like there was some force on Sandra that wasn't on the arm. Like, how come she has a different gravity than the arm does? And then everybody on the crew, I mean, the dialogue, they're all yelling back to Houston as if somehow Houston's going to help them right here.
Houston, I've lost visual, Dr. Stone.
And George Clooney is referring to this other astronaut as Dr. Stone, like they haven't really met each other yet. And he's asking permission from somebody, I don't know, to go and help her out. I mean, it's not astronaut behavior, it's not logical behavior. It's so execrable from an actual practical demonstration of what the reality of spaceflight is like. The most experienced astronaut in American history is a woman. It's Peggy Whitson. She's been in space longer than any other American. She commanded the International Space Station twice. She's done 10 spacewalks. She was NASA's chief astronaut. In this movie, Sandra Bullock has only been an astronaut for like less than a year, and when she's faced with the problem, she's panicking and has no idea what to do. And George Clooney is driving around like some sort of space cowboy as the only person who really knows what's going on. And it's like they met when they were out on this spacewalk, and then it's like he's trying to pick her up during a spacewalk.
Prototypes, even for your pretty blue eyes.
And what is he even doing out there, driving around in his jetpack? I mean, we don't go outside recreationally. It's so different than the actual people that are exploring space, that devote their lives to being astronauts, that are actually on the space station right now. The wonderful human role model examples we have of people who are doing these things, I think it set back a little girl's vision of what a woman astronaut could be an entire generation. Sandra Bullock did a great job of portraying this character in the movie, but I just think the character that they wrote for her was really disappointing. That's what I would have changed. Get the characters right. Get it to represent what astronauts are actually like, and then build the story around that. Don't just make it the perils of Pauline, where she's strapped to the train tracks and she needs George Clooney to magically appear next to her to tell her which book to open to be able to do the right thing. Real astronauts recognize the seriousness of their job. The fact that it's always life or death, and that we're there as the representatives of 7.5 billion people. Everybody's trusting us to be good at this, to have spent decades getting good at this. If you want to know what a spacewalk looks like, there's never been a better movie, though, than Gravity. That opening scene is magnificent for the visual impact and the beauty of the silent turning world and the resolution of each of the fine things and the lighting. It's wonderfully good. So it gives you the raw emotional sense of a spacewalk. Just don't pay attention to what the astronauts are actually doing. This movie is Passengers. So if you're going to get on a ship and you're going to be on it, you know, between stars, going to settle some planet in another solar system, you can't be floating weightless the whole time. Who knows what your babies would be like if they were conceived and developed and tried to grow without gravity. You know, their bodies wouldn't grow right. So how do you make gravity if there's no planet nearby? One way, of course, is just like we do in a little experiment where we spin it in a centrifuge. You can spin the whole ship, and then everybody is sort of pinned against the outside of the ship just by the centrifugal force, and that feels sort of like gravity. If you shut off the spinner, then it would continue to spin for quite a while. There's really nothing to slow the spin down. And that's one of the big scenes in Passengers. The ship has a problem, it stops spinning, and therefore everything becomes like on the International Space Station and starts floating. So I'm not sure why, when it starts losing power, the ship suddenly starts slowing down. You'd actually have to put big brakes onto it to stop all of that metal from spinning. I'm not sure why the ship didn't just sort of blithely keep on spinning as it drove into the asteroids. But would have been a worse story if that had happened. So let's say, all right, the ship stops spinning, now everybody's got no gravity, and one of the characters is in a swimming pool. So what happens to water without gravity? On board the International Space Station, we played with water all the time. You could squirt it and it would just float there in front of you. It naturally, with the surface tension, goes to a perfect ball. That's the easiest shape for it to go to. So if you had a swimming pool held in place by gravity, and then the gravity went away, the water would have some inertia as the ship slowed down, and it would slosh, but then the water would almost look like a big blob slowly forming itself into a ball. And I think that's quite well shown. And the weirdest thing is, if you were in the water at the time, how would you even know which direction to swim? Which way is the surface if there's no up or down? Even if you started swimming one direction, the blob is flexing, and the way you're swimming might be getting further away from you. So that was a very compellingly accurate scene, assuming there's a swimming pool on board a spaceship. The way it resolves, though, it kind of bends the edge of probability, because if you spin the ship back up again, then you generate the centrifugal force and the water would get squished back down into the pool side of the room. But it would take a lot of force and time to take a ship that is stopped, this great big massive metal thing, and get it spinning again. It wouldn't be like nothing and then bang, gravity, like it's portrayed in the movie, where suddenly everyone is going bang into the floor as if gravity was an on-off switch. But that wouldn't have been as visually compelling and allowed the crew member, the young lady, to, on her last dying breath, to burst out of the water and stay alive. We're coming in hot. Oh, yeah. Okay. This movie is Armageddon, which is sort of the disastrous end of everything. And I think that's an appropriate name for this movie. I haven't seen it since I turned away from it when it first came into the theaters. This scene here, where the two space shuttles are landing on an asteroid, you know, with the deep sea worker blaster guys who are going to blow up the asteroid so it doesn't destroy Earth. There are so many things wrong with this that I don't even really know where to begin. Let's start with the fact that they're talking to Mission Control real time. There's no lag. How did suddenly time and space change? You get instantaneous communication all the way out to this asteroid with no lag. And then one of them says, "We're coming in hot." We're coming in hot? Relative to what? What are you talking about? And how do you know that? Do you have some magical landing information about an asteroid so that you know you're going faster than you meant you were supposed to? And then if you watch as the shuttle comes to land, it flares. It slows down so it can touch down on the asteroid, like by pulling back on the stick. There's air on an asteroid. I mean, what made that magically happen? And there's these weird video game displays in the space shuttle that allow you to, suddenly you're flying in the game Asteroids, and the crew is, everybody's panicked and yelling at each other. The big engines on the back are constantly running. Where's the fuel coming from? There's no gas tank. So they'd be accelerating the whole time. So why, I mean, what are they doing that for? It is as atrociously bad as any space movie that was ever done. It's so bad, it's tragic comic. I'm glad they safely landed on the asteroid, but it's just atrocious.
What's the abort force?
7,500.
Anything more than that and the map could tip.
This is the Martian. I like how the one crew member is wearing his name tag in the middle of his chest. It's a little far along in the mission to be wearing your name tag. Mars is an interesting planet in that it has dust storms. We can see them through our telescopes from Earth. And some of those dust storms envelop huge sections of Mars simultaneously. This is, unfortunately, about the worst part of the whole movie, The Martian, is that the atmosphere is so incredibly thin on Mars. It's almost like the very edge of space. On Earth, you would have to be like 100,000 feet up to get to how thin the air is on Mars. And think of the people that go to the top of Everest, which is only 28,000 feet up. Almost all of them need oxygen just to be able to get to the top of Everest. And this is, 4 times as high as that. If the air was blowing incredibly fast, there'd be so few air molecules going by you that you'd hardly even feel them. And there's no way you could pick up all those big pieces and blow them and knock Mark Watney over. And it's a slow, cumulative change of seasons on Mars. The people that made the movie just decided the gravity on Mars is the same as the gravity on Earth, even though it's actually only 38% of the gravity. So Matt wouldn't be quite that hunky on Mars. He wouldn't be solidly on the floor. He'd only weigh 1/3 as much as he does on Earth, so he'd be a lot more bouncy moving around, and things would move differently. Mark Watney, played by Matt Damon, is trying to find a way to make enough food to last until he can be rescued. All he's really got are potatoes, but potatoes are simple and they grow and multiply. So he needs a few things. He needs water. He needs nutrient-rich soil. He needs heat, and he needs oxygen.
I'm gonna have to science the shit out of this.
It makes sense, actually, that they're growing plants on Mars. If you're going to live there, you can't bring everything in little tins and dehydrated packages. You got to grow food where you go. We've been growing stuff on spaceships for decades, and so the movie ends up being very good for how could you get that little environment for one human being and his crop of potatoes to grow on Mars. The idea of using the human crap from outside in order to harvest the nutrients that you need for potatoes, just like putting manure on crops at home here on Earth. How he used existing chemicals, whether it was rocket fuel or whatever, they're all just sort of hydrocarbons, things with hydrogen and oxygen and carbon in them. And so long as you can get the right chemical reaction, you can get out the things you need. And if you think about it, that's sort of what happened on Earth. We didn't used to have oxygen on Earth. It's just a chemical process that created our atmosphere here on Earth. And Mark Watney, Matt Damon, is sort of hastening that process on Mars.
I am the greatest botanist on this planet.
One of the best parts of The Martian is that it came from the book by Andy Weir. He's a really smart guy and an engineer, but he also crowdsourced the science. As he was writing the book, he put it out there and said, hey, everybody, tell me what's wrong with my science here. What am I doing wrong? As an astronaut, Mark Watney could have been just any of the people in the astronaut office. It's that type of person. The deep academic background, the strong operational sense of what you're going to do next. I think it gave people a sense of what being an astronaut is like. There's some hard, sad, difficult parts, but there's some ridiculously fun and almost always joyful parts to it, and a great sense of camaraderie. Better than almost any space movie, The Martian shows that. Apollo 13. Apollo 13 tells the story of an explosion that actually happened on the way to the moon. Really good movie. Maybe the most realistic of all of the space movies.
This is Houston. Say again, please.
Houston, we have a problem.
When you're talking on the radio, of course, the first word you have to say is, who are you talking to? So that's why, from a spaceship, the first word we say is Houston, or Moscow, or Tokyo, or whoever we're talking to. Mission Control is sitting there, and if they hear the commander of the ship say, Houston, we have a problem, it's an understatement, but it has a huge impact. All normal operations cease, and everybody is now listening to hear what the commander is going to say next, looking at their data like crazy. It's a wonderful, succinct way to phrase it, and all space commanders since then, self-included, have used that phrase when needed because it has the desired effect.
Yeah, Jim, could you check your CO2 gauge for us?
if you've lost a bunch of your oxygen and a lot of your purification equipment, how do you get the carbon dioxide out of the air on board a spaceship? You need some sort of scrubbing equipment, and when you've had a malfunction, maybe it's not going to work the way you planned, but they had the lunar lander. It had its own carbon dioxide scrubbing system. The trouble is they were built by different companies. The pieces weren't interchangeable. The engineers recognized the problem early. They presented to the flight director, Ed Harris, doing a great job of playing Gene Kranz, and Gene saying, okay, I understand the problem, now go fix it. That happens every day in spaceflight. Maybe not that dramatically, but I worked in mission control. It's this great detective hunt every day of how can we take what we hope to do, which is now being ruined by the reality of everything going wrong, and we're constantly reinventing stuff, and all the people in the back rooms are trying to figure out the solutions to the problems. But the way it's portrayed in Apollo 13, it was a terrific, dramatic example of it, but it's almost a textbook of what actually happens to solve problems, to get something done. Ron Howard, when he made the movie, I mean, he tried to restrict the dialogue between mission control and the space capsule to be actually what the transcripts of what the crew had said back then. Ron actually came to Houston, spent time with us there, saw what the houses were like. He came down to launch. He really wanted to get to know what astronauts and everybody else at the Johnson Space Center and in the space business were like. I really admire the team that put together Apollo 13, and I love the movie. I think it does a great job of showing what space flight is like, especially at that moment in time.
Time is represented here as a physical dimension. You have worked out that you can exert a force across space-time.
Gravity.
Well, I'm just confused now. This is Interstellar. If you get sucked into a black hole, I mean, people are worried about the riptide at the shore. You know, this is like a riptide, a tyrannosaur riptide. This is beyond our ability to imagine the scope of the forces that are involved. And not just a force like gravity holding us down to the surface of the Earth, but a change in gravity with distance, because gravity, the strength of it is proportionate to where the black hole is. Closer you get, more gravity you get. It would be just tearing everything to pieces until eventually the forces are so high it even sucks light into it. It's not something you can build yourself a tough little capsule and somehow penetrate. There's nothing we know of right now that could withstand the destructive force of being near a black hole. How that's going to be portrayed in a movie, you can kind of do whatever you want with it for now.
Love is the one thing we're capable of perceiving that transcends dimensions of time and space.
Nowhere in a mathematical equation is there a symbol for love. It'd be a nice little heart, I guess, but I don't know how you'd multiply it or divide it. Maybe for the arc of an artistic story, then love is the only way to get through to the end. To end up at that place looking through into his daughter's library rack, it's very emotionally nice. But I'm not sure that Einstein or Stephen Hawking would have followed the logic.
I brought myself here. We're here to communicate with a three-dimensional world.
So how do you deal with time travel, which is essentially what happened here? It becomes so confusing. It's almost like the movie needs footnotes and scientific subtitles here so that you can clue in the viewer as to what's happening. Also, there's no point in yelling through your spacesuit. Nobody can hear you outside your spacesuit. I'm also really confused just by the physicality of what we're looking at. I mean, suddenly he's in some sort of huge filing cabinet, the endless land of Venetian blinds. The movie creators had some specific thing in mind, trying to take the physics and the math and make them three-dimensionally compelling. It still ends up, for me, just being quite puzzling. Interstellar has a fascinating history of birth. It was the brainchild of one of the best physicists in the world, a guy named Kip Thorne. And Kip was trying to figure out the math of what happens around a black hole. And he hired a company called Double Negative, and they took his math and turned it into the raw visuals of what a black hole would look like, and that became the genesis of the movie. It's a real interesting coupling of a science fiction story based very much in an experiment of how to visualize the non-intuitive complexity of what the environment would look like around the weird singularity that is a black hole. The reason the time is dilated for the crew in Interstellar is just because of the incredible change of gravity, the distortion of time due to the huge gravitational forces. But what that means is, if you get going faster and faster and faster, time passes differently for you than someone who's not going that fast. And so while I was on the space station, I had some people do the math to see, was I aging faster or slower than people on Earth? I'm actually younger than I would have been if I'd stayed on Earth for the whole 6 months. Every month, I aged about 1 millisecond less than people on Earth. So after 6 months, I was 6 milliseconds younger than my family. Doesn't mean anything. But if you extrapolate it to the speeds and the physical conditions of interstellar, then suddenly the difference becomes huge.
I've waited years.
Where a fixed amount of time for Matt McConaughey and his crew would be a wildly different amount of time for people who are in a different set of circumstances. It doesn't intuitively make sense. You just have to sort of accept that the world that we live in is only one particular set of physical circumstances, and some wildly different ones exist in other places in our galaxy and in the universe. This movie is First Man, the story of the very first human being to walk on the moon, the story of Neil Armstrong. Didn't that altimeter say he was at 45,000 feet? Before astronauts become astronauts, they always have some other significantly complex technical profession. A lot of them used to be test pilots, and that includes all 3 of the astronauts in Apollo 11, including, obviously, Neil Armstrong. And there's the opening scene in the movie where he is flying an X-15 right at the edge of the envelope, right at the edge of its capability. One of the biggest problems with the scene is sound. It's sort of like he's in a pickup truck driving across a field with this big whiny noise that tells you just how fast he's going all the time. And you can hear it sort of going up and down, like maybe there's a big, I don't know, piston engine running nearby. It's all completely wrong. You don't hear that in the cockpit. And the vibration, there's so much little rattly vibration. Where's that coming from? He's in a bullet plane with a rocket motor on the back. The vibrations would be imperceptibly small. Airplanes, especially airplanes like that, fly really smoothly. Also, he keeps going in and out of cloud. He's at 45,000 feet. What clouds are there at 45,000 feet? There's maybe the occasional thunderstorm that sticks up that high, but you would not fly the X-15 through one of those thunderstorms. And then it goes from this weird sort of rattly kind of noise, like it's some old jalopies flying, to then suddenly dead quiet. Then what happened there? Where did all that sound come from, and where did it all go? And as the pilot also, he's wearing a pressure suit. He's got a headset on. He's inside a cockpit. You don't hear any of that. As he pulls back on the stick and starts going up to get the X-15 up high, that's fine. Once your rocket lights, then you want to start going up where the air gets thinner and thinner. Well, the sky, oddly enough, gets lighter and lighter. Like the sky goes from sort of a normal blue to like this light blue. That's the opposite of what happens. As you ride a rocket up to space, it goes from light blue to dark blue because there's less and less air to refract the light till eventually it goes black. In this clip, for whatever reason, it goes from regular sky to light blue, and then suddenly, bang, the sky turns black as if he like went around a corner or something. The front of the X-15 starts glowing with the heat. Well, that's because of the friction of the air as he's going fast. It doesn't happen at the right time. You know, up where the air is the thinnest, and they didn't really show what speed he was going, the time it takes to heat the front of an airplane and the amount of air molecules that have to hit it to cause the friction and the drag to make all that heating and make the metal glow a different color. It almost looked like he got to space and then the nose got hot, and those two things aren't related to each other. What disappointed me most about First Man was how sad everybody was. Everybody inside was glum, and spaceflight is joyful. It's hilarious. It's magic. You can fly. You're seeing the whole world. These guys were going to the moon. They had a lot of responsibility, but where is the spark of joy that is there in every second of the time that you're on board a spaceship?
The distance from launch to orbit, we know. Redstone mass, we know. Mercury capsule weight, we know.
You did the math.
I look beyond.
I really like the movie Hidden Figures. It tells a story that most people don't know about. It highlights a group of people that did really pivotal work to get us into space at the beginning. And it's a really nice human story, and it's really well acted. There's one scene where the character, Katherine Johnson, who's of course one of the real brilliant human computers that's in the movie, is trying to solve one of the math problems you have to solve for orbital mechanics and getting people into orbit and doing it accurately enough. It's super oversimplified and dramatized, and it's like the entire staff of NASA is 15 people in this one room somewhere. And the part played by Kevin Costner, he's like the leader of this team, and he seems to be the administrator of NASA, and he seems to be the flight director of the specific mission. But you got to simplify things to tell a story, and I guess that's okay. But people sitting in front of blackboards, postulating and coming up with ideas, that's real. That's realistic. That's how we figured out a lot of those things.
Maybe it's not new math at all.
It could be old math. Euler's method.
There's nothing unusual about saying that this is old math. All math is old. It's just whether we've figured out what the mathematical principles are or not. One of the guys who figured out a lot of the math was a guy named Tsiolkovsky, who was a math teacher in the 1800s. He figured out spaceflight with his mathematics by candlelight in his house in rural Russia. And Euler came up with some equations that are absolutely necessary for us to be able to do the predicting properly in order to do rendezvous and burn the engines at the right time that you're going to get to where you want to go. But I love the interplay of the bright minds and the kind of quirky people that actually allowed early spaceflight to happen.
But we have what looks like unidentified rovers approaching our position. Possible pirate activity. And I got a couple of VIPs with me.
This is the movie Ad Astra, the chase scene on the surface of the moon between the bad guys who are in black moon rovers and the good guys who are in white moon rovers, making it easy for those of us on Earth to follow along. Guns work fine without air. Guns don't need oxygen to work, really. If you think of what happens inside a bullet, you know, there's this striker in the back and it causes a chemical explosion, and it's the exploding gas inside the confines of the rifle that make the projectile come out the end really fast. That doesn't count on gravity, and it doesn't count on Earth's atmosphere. So a gun would work fine on the moon. In fact, we actually carried guns on board the Russian spaceship that I flew. When I went to the Russian space station Mir in 1995, the ships that came up had guns in them, but they were in the rescue pack, because if you did an emergency deorbit from the space station, you might land anywhere on Earth, and you might land in a place where there were, you know, grizzly bears. And so there was this specially designed gun that had 2 shot barrels and 1 gun barrel, so that you could fire 2 shots at the grizzly bear and maybe the last one for yourself. I don't know. But we've had guns in space before. Never fired one in space that I've ever heard of. On the moon, there's about 1/6 gravity as there is on Earth. So the bullet's going to fall more slowly than it would on Earth. It's going to take longer to hit. So that means the bullet with the same speed horizontally would go further. It'd go further around the moon. It's possible, I guess, if you had a big enough gun, that it would get to the speed where it might actually be able to escape from the moon. It could get to escape velocity, where it was going so fast that by the time the pull of gravity of the moon kept bringing it down, it would be far enough away that it would have the inertia to float away from the moon forever. I haven't done the math to figure out exactly what that speed is. I'm sure we could make a big enough gun to do that. Why are they driving Apollo rovers around in the future? Those rovers were built in a great big hurry during the Apollo program to try and let the exploring astronauts have slightly better range and explore more of the moon. We would not build rovers like that in the future. That's like if you were watching some movie in the future and they brought in a Model T Ford as the vehicle that everyone's racing around in. It's like, why are they driving Model T Fords? You know, those were from the 1920s. That doesn't make any sense. As you watch this scene, where is all the noise coming from? You are in a perfectly empty vacuum on the moon. So as you watch this scene, it's really noisy. You can hear the vehicles bouncing along, and you can hear the guns being fired, and you can hear them hitting and everything. There's no air on the moon. If you make a noise on the moon, there's no way that the pressure wave can be carried anywhere. You can't hear anything that doesn't happen inside your ship or inside your suit. Like it's as if there are, I don't know, Mel Gibson driving around in some sort of dystopian future, and you can hear the great big vehicles behind him. It would be perfectly silent the whole time. All you would hear was everybody breathing and talking to each other. So I guess it makes it familiar for people, but it's wrong. Perhaps the greatest space movie of all time, 2001: A Space Odyssey. Arthur C. Clarke's great book, amazingly portrayed in the late 60s by Stanley Kubrick and his team. When I came back from my first space flight and sat in my living room with my wife, I remember telling her, it was amazing how you see the world, the speed you're heading over the world, the big curve of it. It's exactly like they guessed it would be when they showed it in 2001. The imagery of it as that ship that left Earth and is coming up to dock with the rotating space station, the sort of gigantic slow ballet of spaceships. At the time, I remember thinking it's like, elephants mating, this big, ponderous, careful, three-dimensional activity with a specific purpose in mind. That's what it felt like to fly a ship up to try and dock with a space station. The little pen floating out of the passenger on board who has fallen asleep. And now the flight attendant walking down the aisle and having Velcro on the bottom of her shoes matching the Velcro of the floor. The inside of the International Space Station, there's Velcro everywhere. Anywhere you want to stick anything, including that pen, there's Velcro on the pen with the one type of Velcro, and the wall is the pile or hook. She did sort of stumble though, which was obviously a gravity thing if you watch it really close. But the idea of placing one foot, then placing another foot and peeling them, almost like someone walking up a wall of ice or something, that was an interesting solution to the problem. I think it's beautifully, artistically, and quite scientifically portrayed. It's great. This movie is WALL-E, really designed for kids, very sweet. In this scene, WALL-E is out there flying around in space and having fun using a fire extinguisher. And Eve, the more advanced robot, has own propulsion system. I'm a little confused about Eve because Eve's head isn't attached to the body, but there's this weird sort of red cable umbilical on the outside. What intrigued me was how the animators moved WALL-E around by firing a fire extinguisher. And it would work just fine. You get a fire extinguisher, you pull the trigger, all that stuff flies out of the fire extinguisher, and if you don't brace yourself, it'd sort of push you over on Earth. If you're floating in space and you can't brace yourself at all, it's going to propel you just like a little rocket motor. And they were clever enough to make sure that WALL-E always got it down to the center of his body. Because if you did it up by your head, then it would push you off center. You just sort of pinwheel. But if you can push it through the middle of your mass, middle of your body, then it's going to move you in a straight line. And he's very careful to constantly move the nozzle to the right spot. It's quite cute and quite a nice little study of orbital mechanics. The very first American spacewalk, when Ed White went out, he actually had one of those squirters with him. Not a fire extinguisher, but a little handheld squirter that he could maneuver around with. Eventually we found it was an impractical way to move. You're better just to put handholds on the ship or wear a jetpack. But that same thing that WALL-E's using, that was actually used by the first American to ever walk in space.
Ladies and gentlemen, Mercury.
This is Sunshine, a movie about a crew having to reignite the sun. But in this scene, the crew recognize that they're going to see Mercury go between them and the sun. It's almost like a tiny little version of an eclipse. And people love eclipses. It's almost mystical. It's a neat thing to see. And so I think that would be natural. The crew would love to see Mercury highlighted against the light of the sun. In the scene, though, Mercury is whipping around the sun. I mean, just in the time it takes those people to sit and look out the window, it goes probably an eighth of the way around the sun. In Earth days, Mercury takes like months, 88 days or something to go around the sun. So you wouldn't perceive the motion relative to the sun, just looking out the window like they are. Also, the sun is stupendously bright. How are you seeing Mercury against the sun? It's like staring at the headlights of a car and trying to see, a marble or something. Your eyes would be so overpowered by the brilliance of the sun, unless they've got some really great special filters somehow on their viewing screen in their ship. What's nice about the scene is the sense of wonder, the awe at the majesty of the reality of the rest of the universe, and seeing it firsthand. I've been around the world 2,650 times or so, and I never once could see enough of it. During my first spacewalk, while I was outside in the dark, we actually were far enough south that we went through the Earth's aurora. It is so fantastically beautiful. and such a raw, artistic, human experience. To look at the Northern Lights is like magic. To be in them, to surf on them, that's beyond magic. It's surreal. My last orbit of the world was even more rich and magnificent and awe-inspiring than all of the ones before it. The unheralded beauty of our planet and of where it sits and the environment that we're in is so constantly magnificent that when you're looking at it, you talk in hushed tones. You know, like you've walked into a giant forest or the most beautiful cathedral on earth. You don't talk in a big brassy voice there. You're reverential of where you are. And I think that little scene gets some of that, the reverence and understanding of both the minuscule nature of being a human in the enormity of the universe, but also the enormity of being able to see it in that way, the huge awareness that we have of our ability to try and interpret it and understand it. I think they portrayed that well. I'm Chris Hadfield. I love space movies. It was nice to have a chance to look at some of them with you. I look forward to every new space movie that comes out, and hopefully maybe some of the things that I've said here will help you see each of the new space movies that you see through an astronaut's eyes. Happy viewing.